Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 14th, 2025, just 2 days ago. This paper shows that even top models like DeepSeek R1 can see their accuracy drop by over 29% when asked to solve multiple problems at once. The paper is titled, REST, Stress Testing Large Reasoning Models by Asking Multiple Problems at Once. And the implications for how we train more robust models are quite significant. It argues that current evaluation methods are too simple and fail to test a model's ability to handle real-world multitasking pressure. Also, the authors shared their code on GitHub. If you want to try these stress tests yourself, you'll find everything needed to reproduce their results. The repository includes all the evaluation scripts, the data for the tests, and a quick start guide to get you up and running. So to really see this in action, let's look at the first figure. It perfectly illustrates this new evaluation method, called REST, which stands for Reasoning Evaluation Through Simultaneous Testing. On the left, it contrasts the standard single question prompt with the new REST method, which combines multiple questions into one long prompt, creating what the authors call a stress level. And the results on the right for the Math 500 benchmark are just stark. The green bars show accuracy on one question, while the purple bars show accuracy under stress. And for every single model, that purple bar is shorter. Building on that initial visual, this table gives us the full picture across what the authors call large reasoning models, or LRMs. These are AI models specifically optimized for complex, multi-step problem solving. For each model, you see two scores: single for one question, and stress for multiple. The pattern is universal. Every model's accuracy drops. For example, on the Math 500 benchmark, a 7 billion and a 32 billion parameter model look similar in single question tests. But under stress, a huge 22% performance gap opens up, really separating them. These next charts visualize this effect in even more detail across 3 different reasoning benchmarks: GSM 8K, Math 500, and AMC 23. The horizontal axis represents the stress level, which is just the number of questions per input. As that number goes up, you can see the accuracy bars for every model go down. But the crucial part is how the larger, 32 billion parameter models in green, hold up far better than the smaller, 7 billion parameter models in red. This really highlights the method's power to differentiate models. So if larger models are more resilient, the next question is, can we train models to be better at this? These charts explore that, focusing on a training technique called long too short. This method essentially teaches a model to provide more concise, direct answers, helping it avoid what's called an overthinking trap. And the results are quite clear. Across all 3 charts, the models trained with long too short, shown in green, maintain their accuracy much better as the stress level increases. This suggests that training for reasoning efficiency is a key strategy for building more robust models. So, if training for efficiency helps, what exactly goes wrong when these models get stressed? These pie charts give us a fantastic breakdown of the different error types on the AME 24 benchmark. We see things like question omission, where the model just skips a question, and endless repetition, where it gets stuck in a loop. For smaller models, these catastrophic failures, like repetition, are common. But for a state-of-the-art model like DeepSeek R1, the main problems are question omission and reasoning error. This suggests it isn't just breaking, it's struggling with the cognitive load. That question omission error is particularly interesting, and these next heat maps dig right into why it happens. Each chart shows accuracy for questions based on their position in the prompt. The vertical axis is the stress level, and the horizontal axis is the question's spot in line. First, second, third, and so on. And you can see it plain as day. The color is always darkest on the left. This reveals a strong positional bias, where models consistently do better on the first questions they see, and their performance just drops off for later ones. So, putting it all together from the error types to this positional bias, what does it all mean? Well, this work shows that our standard way of testing large reasoning models is missing the bigger picture. The proposed framework, called REST, or Reasoning Evaluation Through Simultaneous Testing, reveals that even top models struggle under pressure. But it also points to a solution: training for concise, efficient reasoning. This seems to be the key to building models that are not just smart, but also resilient. That's our roundup for this week. I'm Alex. Thanks for tuning in.